Hello, everyone, and welcome to our live stream. I hope you're all doing well today. Thank you all so much for joining us. I will be just sharing my screen right now, adding the slides, and we are good to go. Thank you all so much for joining us in our Data Science Lifecycle three-part series. Today, this is the last episode of the Data Science Lifecycle, where today we will go through the actual building of the model of all the concepts that we've learned previously in the last two episodes. So thank you all so much for being here today. And before we begin, as I would like to remind you all that this Microsoft event is part of our Microsoft Reactor Code of Conduct. That being said, obviously we're all here to learn, to make this, a nice, friendly environment. So obviously, if you have any kind of questions, feel free to drop them in the chat box, and just be welcoming, be respectful, and all that stuff. So I'm going to be putting my slides in a kind of full screen, just so it is kind of more clear for you all to see. Please let us know in the comments where you're joining us from. We are actually live from Dubai here at the Reactor. So, as I mentioned, if you haven't been here before, and if this is your first time seeing me speak, my name is Hadeel Shubair, and I'm a regional cloud advocate and data analytics engineer at Microsoft Reactor, Middle East and Africa. So part of what we do at the Reactor is we kind of do these events, we host these events and give these kind of technical sessions alongside speakers, experts, and other cloud advocates, where we kind of talk all about tech, what's new in the field. We kind of talk about even kind of topics that we're really passionate about. My areas of expertise lie around the areas of data science, data analytics, machine learning, artificial intelligence, as well as kind of even exploring other tech topics and fields, such as the rise of the Internet of Things. Even we have like Microsoft Azure and so much more. So please feel free to connect with me on my LinkedIn. Here is it's just like my name, Hadeel Shubair, and on Twitter as well at Shubair3. Let's connect. And that being said, let's see what we have in for today. So, last time, if you haven't watched last week's episode or you haven't been there, I'm just going to give you a quick recap on what we have done. And of course, the link to what the last episode is already live on our Microsoft Reactor YouTube channel. So last time, we actually kind of took an in-depth look, and we kind of explored the different phases and stages we have that kind of make up a data science project. So the kind of concepts that we've explored in depth begin with data acquisition or data collection, where we've collected the data. We've talked about the kind of different sources of data that you can get your data from. Then we moved on to kind of the data cleaning and pre-processing steps. Those are obviously, we have kind of a number of steps that, if you have kind of like raw data, you need to kind of inspect it and kind of, treat it basically if there's any kind of missing values or any kind of errors, and kind of detecting kind of any kind of outliers and being able to kind of, treat them well. Because obviously, if you have bad data, you will kind of have a bad model. Then we kind of moved on to a concept called data exploration or exploratory data analytics. And this is where we kind of explored the data on a high level. This is kind of where we extracted some kind of features, kind of defined or discovered any hidden patterns we had in our data set, and so much more. After that, we've kind of looked at some different data visualization tools, and the different kind of visualization, obviously kind of figures and charts that we have. So we have obviously box plots, histograms, we have line graphs, line charts, and so much more, pie charts. So we kind of even looked at kind of like a high level overview on when to use the right figure or when to use the right data visualization kind of chart. Lastly, we kind of explored on a high level the data processing and analytics step. This is obviously where all the kind of mathematical computation and all the kind of technical programming actually happens. And this is actually what we'll be looking at today. So we're going to be kind of exploring all these concepts and looking at an actual example of predicting if a person has a stroke or not. So we will actually build a deep learning model that shows us exactly what steps we need to take to determine, we want our model to kind of tell us and predict if a person will have a stroke or not. So we're going to be looking at this by the end of today. So please stay tuned to watch that. That being said, our learning objectives for today, so we will kind of be exploring some concepts of machine learning versus deep learning, and then we will kind of look at the architecture of deep learning a bit in more depth, since we will be kind of building a deep learning model. I'll take you through some kind of general vital concepts that you need to know on the architecture, what really goes on behind the deep learning models, because deep learning and machine learning are two separate things. So we're kind of going to explore what differs them from each other. Then we will go through the use case of building a deep learning model, obviously, where we're going to be looking at example of stroke prediction. Lastly, I'm going to give you my tips and tricks on how to get started in this data science, AI, machine learning field. If you are only getting started, if you're a student, if you're someone who's passionate about tech, these tips are for you. So stay tuned to the very end. I'm going to have also some very useful resources that you can also kind of take along with you by the end of this session to continue your learning journey and get started. So also stay tuned for those links. They will come all the way to the end. So let's actually begin by defining machine learning versus deep learning. So obviously, we under the world of AI, or under the umbrella of AI, we have two subsets. So under AI, we have machine learning, and then under machine learning, we have a more in-depth kind of concept, which is called deep learning. So AI is the field that we all know. AI is basically when computers or machines are mimicking human behavior. So we're kind of teaching the AI to actually do what us humans are doing. This is what AI is all about. Then we kind of move a bit deeper. We go into machine learning. And machine learning is a subset of AI. And machine learning is basically the ability of machines to improve with experience. Now, under the kind of machine learning umbrella, we have deep learning. Deep learning, this is where you get kind of a bit deeper. And this is where actually, kind of, you have all these huge kind of computations of multi-layer neural networks feasible. You have all these kind of deeper layers that come from an input layer, a hidden layer, and the output layer. So this is kind of more on the technical kind of deeper side of where like neural networks happen and all that stuff. So this is what we'll be kind of exploring today. So let's look at machine learning first. So let's look at machine learning. So let's say so have this example with me. Let's say we want to build a model where you want you want your model to predict or to detect if to classify if a car is a car or not a car. So the basic flow or process of how you would build this in machine learning is you would have an input. So the input could be like an image of a car, and then it will go through a step of feature extraction. So with feature extraction, the model starts extracting some features of the data set, looking at the parameters and all that stuff. So it will start extracting some features in the data set, and after that it will start by using a classification model, because obviously we want to classify a category. So we want our model to predict if if the car is a car or not a car. So after it does all the computations and all the programming and the classification model is built, it should give you an output or a result of if it's a car or not a car. The deep learning process, however, it could kind of look similar, but it's really just has a bit like more extra layers, if we can say. So let's look at the same example. In the deep learning kind of model, you would also have the input, same thing. Let's say we have images of Tesla cars, and then you would have, instead of having a separate feature extraction and then a classification stage, you would have a feature extraction and classification stage where it kind of has different layers and hidden neurons within the layer. So this actually example of deep learning is actually used for driverless cars, for example. So deep learning is used in driverless cars because it helps driverless cars detect, if a passenger is passing by, or to even kind of differentiate a stop sign from an actual car, and so much more. So deep learning is actually a bit more deeper. It uses more layers that go on kind of behind the scenes of all the computations that we have, and it includes both feature extraction and classification. And of course, we have to always mention deep learning uses hidden neurons. So deep learning actually works just like the way of how our human brain works. Obviously, in our human brain, we have lots of obviously neurons, and we have the brain cells and all that stuff. So it's kind of just layer by layer. So this is how it works. After you have all these hidden neurons and layers and feature extraction and classification, it will give you an output with more kind of details. It will tell you the car or not a car, and it will give you even kind of more deeper outputs. So this is kind of the basic difference of machine learning versus deep learning. Let's look at the machine learning algorithms that we have already discussed kind of last time. So under the machine learning umbrella, we have three different types of learning. We have supervised learning, unsupervised learning, and reinforcement learning. And under each, depending on the different type of learning you have the kind of classification, regression, or clustering or decision-making kind of problems or algorithms that you have. So if your goal was you want to classify if an image was a car or not a car, you would use a classification kind of algorithm. And under that, you have the different algorithms that fall underneath. So you can use a decision trees algorithm, support vector machines, naive Bayes classifiers, and so much more. If you want to predict the kind of let's say the sales of the house that you have in the next few years, you want to predict the price of something, or you want to predict a specific number, this is under the regression problem. So you will use any of the regression algorithms below, such as logistic regression, linear regression, and so much more. The same falls for clustering and decision making. So this is the umbrella of machine learning and the different learnings we have and the different algorithms. Now, obviously, you have a lot of different algorithms. You might ask me, Hadeel, if I want to build a model, I have this, I know what my goal is, but I don't know which algorithm to use. I got you. So this is your best guide for the machine learning algorithms. So this is actually a cheat sheet from our Microsoft Azure platform, which kind of really summarizes for you basically exactly depending on what you wanted to, it gives you exactly the different categorization of different algorithms you have, so you are able to kind of narrow down what algorithms you could use depending on your goal and depending on the data and what you want to really achieve with your data. So let's look here. Obviously, so let's see, your goal is you want to classify images. So you have different images of, for example, cancer cells and such. So you want to classify those images. And to do that, you will use an image classification algorithm, and underneath that, you have the DenseNet algorithm. Or let's say you want to kind of predict values, you want to predict the cost of a specific product, you want to predict the sale of the houses and such. So under prediction falls the regression. So you would kind of look at the different regression algorithms you have, and based on that, you would choose the one that's best for you, and so much more. So feel free to kind of obviously scan the cheat sheet here. This is a quick QR code that helps you scan, use your phone, your iPad, whatever it is, to get it and to have it as a guide as soon as you're starting with your data science, machine learning, and AI journey, and to build your models. This is very helpful. It's something that I personally use and love to use. Or I will also post it in the link, but in the chat box at the end. But you can also follow the link, aka.ms/ml cheat sheet. So I will also post this in the end, just in case you did not have a second or two to scan it. Let's kind of now move on to more deep learning. So today we're going to be talking a bit more about deep learning and what deep learning is all about and all that stuff, just at a high level, so we can understand once we build our model how actually deep learning works. So deep learning is actually a subset of machine learning. So it kind of focuses more on deeper layers. So it's essentially, if you could think of it, it's essentially a neural network that has 3 or more layers. It kind of uses interconnected, maybe let's say neurons or nodes in a kind of a layered structure that resemble exactly the human brain. So if we kind of think of our human brain, obviously there's like a lot that's going on. So you have these neurons that are connected to brain cells and so much more. So this is where neural networks attempt to simulate the behavior of us, the human brains, to allow it kind of to learn from the large amounts of data that you give it. Now, additional kind of hidden layers are in neural networks really help optimize and refine for accuracy of the models. That's why we have these hidden layers, output layers, and input layers inside. And obviously, since neural networks attempt to mimic the human brain, this means it kind of enables like systems and machines to basically cluster the data and help make kind of predictions with absolutely incredible accuracy. So Some real life examples of where deep learning is actually used, as I mentioned previously, you have driverless cars. So, for example, Tesla. Tesla is basically uses deep learning to help kind of recognize a stop sign or to even distinguish like a passenger from like a tree in the street and so much more. And also you can see deep learning be applied in kind of the healthcare industry. So for it's used for medical image classification, where it classifies medical images and medical diagnosis from each other. So deep learning is actually kind of used in most fields today, but they kind of focus on more kind of, let's say, more kind of heavy computational programming, and it does kind of more, if you have like a problem or something that kind of needs lots of data to process and layers and such, this is where deep learning is applied. So let's look at the actual architecture or structure of how a typical deep neural network could look like, such so we can have a clear idea together. So the first thing you have an input layer. So the input layer is basically the initial data that you give for the neural network. An input layer could be like the image of the car that you have. Next, you will move on to kind of multiple hidden layers, and they could be three or more. It really depends on the data that you have and the goal that you have. So with these multiple hidden layers, these hidden layers fall between the input layer and the output layer, and they are the place where all the mathematical computation and programming is basically done. So everything that really goes on behind the scenes of the building the model and all that stuff, this is where it all happens. Lastly, you will have the output layer. So the output layer is basically the result for the given input. So input, hidden layers, output. These are the three kind of structures or layers that you need to know when it comes to deep neural network architecture. Now, in neural networks, obviously, as I mentioned, the human brains obviously has billions of neurons, and each neuron is made of a cell body that is actually responsible for computing or delivering specific information by carrying forward kind of information towards hidden neurons and providing final output based on what we have. And in neural networks, you tell your network the input that you have. So you give it the input, and based on what you have, it will give you the output and learn on its own. So in neural networks, there are some things to keep in mind. You have a dense layer. So dense layers is basically it's the dense layer. It's kind of the deeply connected neural network layer. It is the most common and frequently used layer in neural networks, and this actually does kind of all the operation and all the programming on the input and gives us and provides us with the output. And we also have what we call activation functions. So with activation functions in neural networks, they actually help kind of define the output of the node. So we would use some specific activation functions. So we have a sigmoid function, which is used for logistics regression, or we have the 10H or the ReLU. So really we have a wide variety of different activation functions that we have that can help by kind of seeing if the kind of layer is activated in a way or not. So underneath the deep learning algorithms, obviously, it falls underneath the two different categories. So we have supervised deep learning and unsupervised deep learning. Today, we're going to be focusing on basically the supervised deep learning, just to take it as a simple example to help us basically understand once we want to build our first deep learning model, what can we use and how basically the process actually flows. So underneath the supervised deep learning category, you have kind of three different deep learning algorithms that you can use. So you have artificial neural networks, ANN, convolutional neural networks, CNN, and recurrent neural networks. And underneath the unsupervised deep learning, you have server organizing maps, Boltzmann machine, and autoencoder. As I mentioned, so today, since we're going to focus on supervised deep learning, just to serve as an example on what basically how neural networks actually work. So now, enough with all the talking, let's actually look at the model that we have. So today we're actually going to look at a use case where it kind of shows us how we can actually build a deep learning model to predict if a person has a stroke or not. Let's look at it together. So I'm going to move on to the next screen that we have. And obviously I am seeing as obviously, I mentioned before, I wanted to know where our audience is from. I am live from Dubai. Hi, Orlando. Thank you so much for joining from Colombia. Please let us know in the comments as well where you are joining us from. So let's look at the actual example we have to predict the strokes. I am going to zoom in a bit just to make sure everything is clear. So As I mentioned in this example, let's walk through the actual steps on how we can actually build a neural network model that basically identifies the possibility of a stroke prediction happening for a person. So by the end of this, we want the machine, the machine model, the deep learning model, to actually predict if a person has a stroke or not. So in order to do that, let's begin by seeing the basic steps. So the first thing we're going to do is we are going to import our data. So in order to import our data, we will be using the stroke dataset. And the features of the dataset that we have are as follows, as you can see. So we have a unique ID for each patient. We have the gender of the patient, whether they are male or female. We have the age of the patient. We have the hypertension. So it will be categorized into 0 or 1. So if the patient does not have hypertension, it will be categorized as 0. If the patient has hypertension, it will be categorized as 1. We have if the patient has heart diseases, it will be categorized as 1 or not, it will be categorized as 0. If the patient is married or not, no or yes, the different work types. So are they stay at home moms and dads, or they have, or do they work in a private sector, are they self-employed, and so much more. The type of residence, whether it's rural or urban. The average glucose level of the patient in the blood. The BMI, the body mass index. The smoking status, so if they ever smoked or not. And the stroke, which is our main parameter here, and our main goal is 1 if the patient had a stroke, or 0 if the patient did not have a stroke before. So obviously, since we're looking at a stroke prediction kind of example, and this is the data set we have, the kind of primary, feature that we actually is very important to look at is basically the stroke. So it will be 1 if the patient had a stroke, or 0 if not. So we start, as I mentioned, by starting by importing the necessary libraries that we have. So we start by importing the necessary libraries in any kind of data science project. So we will kind of use NumPy and Pandas, and NumPy for kind of mathematical arrays and computations, Pandas as well for doing the data manipulation, kind of all the kind of data manipulation, obviously work. So in order to import our libraries, I'll just zoom in just one more just to make sure this is clear. We will import the necessary libraries. So by running this line of code, we make sure that our libraries are imported. Now we start by loading our dataset. So we're going to start by loading our dataset inside this notebook, and we will load the dataset from a CSV file, and then start by looking at the first few rows. So we want to look at the first few rows in order to kind of get a clear idea of how our dataset actually looks like. So by running this line of code and by using the data.head function, this actually helps us kind of display the first few rows of our dataset. So by running this line of code, this is what we get. We get this kind of table or overview. So we have, as we see, all the different categories and the different features. We have the rows and the columns and all that stuff. This is basically by using the data.head function. So now that we've seen the different categories that we have in our data set, the different rows, the number of columns, and all that stuff, let's actually go more in depth and go into a kind of high level data exploration on our data set. Now, we perform data exploration or exploratory data analytics in order to kind of help us discover any hidden patterns we have in the data set, to kind of identify any kind of unique identifiers. Even if we have like any kind of relationships between features, this would also, exploratory data analytics actually helps us do that. So let's start by exploring our data set by using EDA. So to begin with, we're going to actually look at the shape of the data. So what do I mean by shape? Means we want to see the number of rows and columns, or the number of examples and features that basically we have in our data set. So obviously we're not going to go to our data set and count one by one and see how many rows and columns. By simply using this line of code, the data.shape function, this actually helps us display that we have 5,110 examples or rows and 12 features or columns. And we can actually confirm that by going just to look up. If you count these are the different number of columns that we have, which are 12. So this, by using the data.shape function, it actually helps us do that. So we've actually seen how many examples and how many features we have. Let's move on to let's see the different types of columns that we have in our data set, so we can see the types of each feature we have in the data set. So to do that, we actually use the data.info function, which is as here. And after running this line of code, it will give us this. So what does it give us? It gives us the columns that we have, and if we have any kind of non-values or missing values in each column, the count, and the different type of feature in the columns. So if the feature is an integer, it's an object, is it a float, and so much more. So based on that, we can see the let's look at the non-null values here. We can see that we have 5,110 columns, 5,110 rows actually. And based on these, we can see here that the BMI column has a 4909 number, which is obviously means that we have some missing values in the BMI column, which means that we have to treat it later. So this is something that we need to remember in the data cleaning and pre-processing step. This is something that we have to look at and treat. So this is why I love the data.info kind of function. It helps us have an overview of what really is available in our data set to kind of get a clear idea of the different types of features. Also, it gives us the number of rows and examples, the total of columns, and so much more. And it even gives us the memory usage as well. So that being said, we have explored the different types of columns we have. Now let's move on to the next step. So obviously we've seen that our dataset has different categories, such as smoking, such as gender, work type, residence type, and so much more. Obviously, to build a model, you need to kind of convert these categorical variables into kind of numerical variables. But before we do that, we will start dealing with categorical variables, and we want to kind of walk through each categorical variable we have in order to see the different categories we have and the counts of each one of them. In order to do that, we will run this line of code. So basically, we will specify data, and then we will specify here the exact column that we have, which is we want to look at the smoking status column, and then dot value underscore counts, and this is the line of code. So after running this line of code, it shows us the different categories we have, obviously, in the smoking status. So how many people have never smoked? We have 1,892. We have 1,544 people who are unknown. We have 789 who smoked, and formerly smoked 885, and it even shows the type of the column. So we will do this for each column. So we've looked at the smoking status. Let's look at the residence type as well. We will do the same just by specifying, obviously here, by running this line of code and specifying the column that we have, which is the residence type. It will show us how many people live in an urban area or rural kind of residence area. Next, we will move on to the work type category. And to do that, we'll do the same exact thing. It shows us how many people work in a private company, how many are self-employed, how many have children and are not working, how many have a government kind of job, how many have never worked, and more. We will do the same to check the categorical features for the ever married column. So if the person has ever been married or not, it shows us here the numbers for each. Then we move on to the hypertension column as well. So as I mentioned, if the person does not have hypertension, it will be classified as a 0. If the person does have hypertension before, it will classify as 1. So we have 498 people. For that, let's move on to the last two columns we have here. We will do the same for the heart disease to see if our patients obviously have had heart diseases before or not, because this obviously plays a big role in our kind of predicting the stroke. So to check, obviously, we can see that we don't have the number of patients that actually had heart diseases are 276 patients. The rest of our data set did not have any heart diseases. Lastly, we will look at the stroke column. So if the patient has had a stroke before or not. So we can see that 249 patients in our data set have had strokes before, and 4,861 did not have any strokes. So this is kind of an overview on this kind of function that you could use that helps you basically identify, the counts of each of the features that you have and the type. Now that we've seen the value counts for each, we've kind of understood the different categorical features that we have and the columns and that and such, we will move on to the next stage, which is the data pre-processing stage or the data cleaning stage. Now, this is something we've already explored before in our previous two sessions of this kind of series. So with data pre-processing, we're basically treating any kind of outliers, missing values, any errors that we can detect in our data set, and basically any null values, converting categorical features into numerical features, normalization, and so much more. So this is basically where you actually look at your data set and kind of treat, obviously, each different kind of a missing value or null value and such in its own way. We've talked about the different ways we can deal with each one of them, like outliers. You can use box plots for detecting outliers, or for example, dealing with nulls. With nulls, you can there are several ways to deal with null values. You can kind of replace the null or fill it with the mean value, and so much more. So you can have a look at these in the previous sessions that we've done, or the recordings also available. So we will look at our data set and start with, as we mentioned before, we have seen that the BMI column, if you remember previously, has some missing or null values. We need to treat that, and in order to do that, we will fill the null with the mean value. This is one of the many methods that you can use to deal with nulls. So we will specify by running this line of code the column that we have. We will use the fill na function, which fills for us the actual box with the mean value, and we will replace it with the mean here, specifying that it's true. And in order to do that, we can confirm that our kind of missing value is actually replaced with the mean value. So we did that, and that's good to go. Next, we will start by encoding some categorical features. In order to encode categorical features, we want to kind of obviously make sure that the categorical variables that we have, we're able to use them to train our deep learning model. So this is a very important step to do. So we will run this line of code by specifying the different, obviously, categorical features that we have. And by running this line of code for each one, we make sure that all of the variables are encoded. And this helps, obviously, our deep learning model understand exactly, that the variables have been encoded, the features have been encoded, so we're good to go. It will kind of give a better performance and understand, the deep learning model will understand how to be trained and such. Next, we have confirmed by running this line of code that we have encoded our categorical features. As part of the data preprocessing and cleaning step as well, we need to make sure that our features are normalized. So by normalization, we want to make sure that our values range from 0 to 1. So we are able, obviously, once we have some hyperparameters and we do some tuning, that we have values of accuracy, recall, precision, and so much more. So this is something that we do. To normalize our features, we will normalize the input data by dividing the maximum value of each column. So we will take the maximum value of each column by running this line of code, data.divide, and then we'll give the maximum value of each column, specifying axis is 0, and by running this line of code, we can make sure that our data is normalized. To double check, we can use this function, which is data.describe, and this data.describe function also shows you kind of more in-depth details on how your dataset has looked like, and even like the mean of each column, the standard deviation, the minimum and maximum values for each column, the first quartile, second quartile, and third quartile, and the count as well. So as you can see here, first quartile, which is the 25%, it gives us the value for the 50%, second quartile, and third quartile gives us the minimum value for each of the columns. So and the maximum for each of the columns, and so much more. And here also from the data describe function, it also kind of shows us that after we run this line of code that our data is normalized, we can confirm that all our data here is between 0 and 1. So our data has been normalized and it's ready to go. We can also confirm that if you can recall that we had a missing value or a null value in the BMI column. So we can confirm that this BMI value is also filled here. So we have 5,110 rows, and this has been treated and it's working well. So after we've used the data.describe function to kind of show us an overview of our data set, the minimums, the minimum, the maximum value, the standard deviation, the mean, and the first, second, third quartiles as well, we will move on to removing kind of unnecessary features. So obviously our goal in this whole kind of use case or case study is we want to kind of predict if a person has a stroke or not. So we will train our deep learning model to predict if any upcoming new patient will have a stroke or not. So obviously the features that we really care about are already there, but really some kind of features are irrelevant, such as the ID or the unique identifier. We don't really care about it, so we will just simply remove it or drop it by using this line of code, the data.drop, and then specifying the column here. And by running this line of code, this actually make sure that we remove the ID feature because really it's not really necessary to the predictions and to what we're doing. So you can do that and you can leave it out. I have done it because really removing unnecessary features just makes kind of, it flow for your data set and for your model to actually focus on exactly what's needed. That's why once you have kind of unnecessary features that are completely so out of your data set, it's best to kind of remove them. Now we've collected our data, we've imported the necessary libraries, we have kind of done some exploratory data analytics, we've explored our data, we have done the data cleaning and pre-processing step. What's next? The actual next step is to actually move on to actually data processing and analysis on building the deep learning model. So in this specific example, we're going to actually build a model which uses which is a sequential neural network model. So to actually obviously build the model that we have and observe the summary of it, we are going to use the TensorFlow library and Keras. TensorFlow is actually an open source library that's actually highly used for deep learning applications and models as well. And Keras is kind of a high level neural networks library that basically runs on top of TensorFlow. So since we're obviously, as I mentioned, our goal is to kind of predict if a patient has a stroke or not. So just to kind of go through the concept that we've learned and such, we will build a neural network model to do that. So we're going to be using the TensorFlow library and the Keras as well. Next, obviously, we want to start by defining our neural network model. So you are basically kind of teaching your machine or your model. Basically, you need to define exactly what model you want it to train on. So we start by defining our neural network model. And obviously, in neural networks, as I mentioned, we have three different layers. We have an input layer, we have hidden layers, and we have output layers. So we can see from, obviously, now we will just go down a bit here. I will just zoom out for it to be a bit clearer. So we will start by kind of defining our neural network model. As you can see, we start by importing our TensorFlow as TF, and this is basically importing the deep learning library that we'll use. And then we will actually define our neural network model. So by adding these different layers, we can see that our model has 7 layers. We have 1 input layer and 6 hidden layers and an output layer. Let's look more. So we will use and run this line of code. So the model equals sequential is basically what it means is this is basically you are teaching and your machine that you are actually creating this sequential model. So by sequential, I mean you have a stack of layers. So this is a sequential neural network. So this is actually what you start by doing. You start by, after importing the libraries, you will actually define and kind of create your model. After you've created your model, you start by adding the different layers you have. So you want to start by adding the input layer, and to do that, you will do the model.add. The model.add function actually helps you add layers to your model. Then you have the dense. You might ask, okay, Hadeel, what is the dense? The dense function is basically used to define densely connected layers, and this is actually obviously frequently used in hidden layers and in neural networks, and it's the most common layer that is used. So this is actually shows any kind of densely connected layers. So we start by defining that we have a dense function, and then we have parameters for each of the different layers that we have. So as you can see in the first layer, we have 32, we have 16, 8, 4, 2, and 1. So these numbers, the 32, 16, 8, 4, 2, and 1, are the first parameters. They are the number of neurons we have in each layer. So it shows in each layer the different number of neurons we have. Next, we have in the first layer, obviously, since the first layer is an input layer, you have to kind of specify the dimension. So the number of input features we have is 10. So we have specified it to be as 10. And then the activation is an activation parameter. So as I mentioned before, in neural networks, obviously, you need to make sure that your function is activated. So in order to do that, we want to use kind of any of the activation functions we have, like sigmoid, relu, tanh, and so much more. And you have to use we want to use one in each layer and then move on to the next one. So we will actually do that and specify the activation parameter. So we will do the same. As you can see here, it's only the first layer that has the input dimension. The rest are hidden layers. And then we want it to give us the output layer, because as I mentioned with the architecture, this is usually how it works. You have to kind of specify the input, and then it will do all the kind of hidden layers it has, and then based on that, it will kind of provide us with the output, which is our goal. So then we will run the model.summary function to give us a summary of our model, how it's built after we have run this line of code. Let's actually look at what it looks like. This basically gives us the type of layer that we have, the shape or the output, so the rows or the columns, and the parameters, the number of parameters we have also in each model. This just gives us a summary of how our model is looking like by using the model.summary function. Now let's move on to actually compiling the model. So what does compiling the model mean? So as we mentioned, we have already kind of, built our deep learning model. We have already defined the neural network model. After we define the model and stack the layers that we have, the input, hidden layers and output layer, we have to compile the model in order to kind of measure the accuracy, precision, and recall to understand basically the performance of the model. So it's very important to know that this is actually a very important step to do. And in neural networks, it happens by doing and adding some configurations. So we add some configurations such as the optimizer function. We have the loss function and some metrics. So the optimizer function actually is used to optimize the input weights that we have by evaluating predictions using some kind of metrics like loss functions. In this case, we have used our Adam optimizer as well, as you can see in this line of code. Then we have what we call a loss function, and a loss function is actually helpful, and it's used to calculate any kind of deviations or like the error rate in the learning process. So as your model is actually learning, the use of the loss function kind of helps detect and calculate any errors or deviations we have. Then lastly, the last configuration that we will use to compile our model is by using some metrics. So the metrics are obviously used. These are performance metrics such as accuracy, precision, or recall metrics, and these are used to evaluate the performance of the model. So basically to see how our model is behaving with using the deep learning algorithm that we have inside. So after I've kind of explained these, this is basically the line of code that you have to run in order to do that. So as I mentioned, this is you will define that you want to compile your model, and you obviously need to define exactly what optimizer you want to use. We have decided to use Adam optimizer for this specific problem. We wanted to use the loss function, and this is what you would use, a binary cross entropy. And then the metrics will be that we want to focus on are accuracy, and based on that, you have the precision and the recall as well. So by running this line of code, we can make sure that our model is compiled to kind of, see exactly how our model is behaving and performing. Now we have compiled our model. What's next? The next kind of step that we have to do is to fit our data. So what do we mean by fitting our data? This is basically where you actually take the data set that you have and split it into training and testing data set. So in any kind of, once you build any machine learning algorithm or a machine learning model or deep learning model as well, this step is actually very crucial, where you need to take most of the data that you need to take, let's say 70% or 80%, has to be going through the training process, and the rest 30 or the rest 20% of the data set will be done and used to validate the model performance and to be used for the testing process. So it's very important that once you fit the data, you are splitting our data set in training and testing. This is where we will actually fit the model on our training data and validate on our testing data. Now, in these examples, the training will happen for 15 epochs. So by 15 epochs, we mean 15 iterations or 15 rounds. So you remember the different, obviously, structure of neural networks. We have input layer, hidden layer, and output layer. So this will actually go for all different layers for 15 rounds. This is basically what the 15 epochs mean. So we will start by actually defining here that we want to do a train and test split, and then we will define it here, and then by running this line of code and obviously fitting the model here by running this line of code to validate the data here, we also specify the number of epochs or the number of kind of rounds or iterations of our model that we wanted to run. We run this line of code, and what do we get? We get this is what you usually get. So you have the different number of epochs here. You have number 1, number 2, 3, 4, until 15. And it basically kind of shows you the loss function, the accuracy, the precision, the recall, the validation loss, and so much more. So this is basically kind of very helpful for us to see, that what is the precision we have, what's the number, the recall number that we have, the accuracy we have, and so much more. So obviously here, as we can see, the precision here, like for any of them, is actually zero, and the recall is also zero. This means that the model is actually not predicting any positive value, so we need to start by improving the model. What do we mean by improving the model? So to improve deep learning models, we start by actually kind of checking for data imbalance. So it's very important to know why we look at metrics so much is because obviously we want to understand that we want to make sure that our performance of the model is working well. And what do we mean by good performance? We mean a good recall and a good precision, which is like a positive number. So since we had a poor recall and a poor precision, we want to check if there's any kind of data imbalance that may kind of cause our model to be biased this way. So to do that, we will actually kind of plot a histogram with using data visualization. So we will plot a histogram for the stroke actual parameter, since that's our goal. And by running this line of code, you kind of specified here that it's a histogram, and the column that you want the histogram to be plotted on is a stroke column. So here it specifies us, it gives us the actual result of the histogram. So as we can see here from this actual chart, that there is a significantly higher number of no stroke patients compared to stroke patients. Thus, we can obviously confirm that we do have a huge imbalance in our data set. And this is why we kind of need to deal with this using the smooth function. Smooth function is actually used to generate basically new data based on the data that we have. So we kind of avoid overfitting of the data. So this is something that you actually do when you have a huge imbalance. So as I mentioned, we're going to be using the smooth function to treat that. And as a result, by using the smooth function here, we will have the same number of examples in each of the two classes instead of having the imbalance. So by running this line of code, here you're importing the smooth function and you're specifying the smooth function. We want to plot it in a histogram as a new histogram to see how it actually looks like with the smooth function. This is actually what we would get. So as we can see previously, we can see here we have a huge data imbalance from the non-stroke patients and patients who have a stroke. Now, after we've run the smooth function, we can confirm that our data is actually, we have an actual balance for the two features that we have. Now, after we make sure that we don't have any data imbalance, we're good to go. We start by actually splitting our data set into training and testing sets. Now, most data scientists and analysts and kind of engineers actually focus on using the 70 to 30 of 70 being a training kind of a set and testing being a 30 kind of test. Or you can actually also train and split your data into a ratio of 80 to 20, 80 being training and 20 being testing. So this is very important because obviously you want to teach your model to go in different rounds and basically understand what basically you're teaching it from scratch how to actually help us predict the stroke. So we're going to start by splitting our data set into training and testing sets. Here we will be focusing on a ratio of 70 to 30 in 15 also epochs, as we mentioned previously. So we will run this line of code where we will also specify the training and testing sets, and we will fit the model and also specify the number of epochs. So here, after we have split our training data set and we've run this line of code, this is usually what we would get. I will just zoom out a bit here for us to see what we have on screen. And this is basically what you have. So what we will see is we have the number of epochs, same thing, the accuracy, the precision, we call the validation loss, the accuracy, validation precision, and much more metrics like the validation recall. Now, obviously, we can see here, let's zoom in now, that from after we have made sure that our data is balanced, we can actually confirm that the performance actually does get better. And since our data is balanced, we can actually see a good improvement. Now the accuracy actually goes to around here, around 0.80% or 0.81. So we have like an 81% or an 80%, which is actually good. So it's a good positive value, but still we can say that there's still more room for improvement. So after we validated that our data is balanced, we have a good accuracy, it's going up to 81%, we want to design a new model that actually uses batch normalization. So batch normalization is actually, it allows to kind of update the layers that we have in batches, and it consequently accelerates training and even reduces the number of iterations or epochs that we have in our deep learning. So we want to start by introducing batch normalization after each layer. So in order to do that, we will basically run this line of code where we were kind of obviously specify that we want to use batch normalization. We will import it, and we will specify the model here and create it. After that, we will do a summary of the model just to see how it actually really looks like. So by running the model.summary function, we can actually see the different, obviously, features that we have for each of the epochs, the shape, the number of parameters, and much more. Now we want to train the model as we have previously done by fitting the data. So we want to train it. So in order to train it, as we mentioned, we will do the same thing by compiling the model, specifying the loss function. The different metrics that we have that we want to focus on is accuracy, and here we wanted to specify. So as we go a bit and run this line of code, we can see that from the different numbers that we have here, let's look at the accuracy. We can kind of see that there is an improvement in accuracy. Most of them are being up to kind of 83 or 84%, which means that we are actually achieving better results with batch normalization with this kind of new model that we built. So that's actually a very good sign. Now that we are done, we've made sure that, we've built another model, we've made sure that we have good accuracy and good results. We will start by actually doing some hyperparameter tuning. This is actually kind of where we actually select a number of parameters to understand the performance of the model. It kind of gives us the metrics of basically understanding the behavior of the model. So it maximizes the model performance and minimizes a predefined loss to produce better results and give us better results with fewer errors, obviously. Now, since the accuracy of the model has improved, let's start by tuning some hyperparameters of our model. We want to do that. So we will run this line of code here. And by running the line of code here, let me just zoom in again. We will tune the batch size to the number of epochs and then select the best set of parameters that gives the highest accuracy. So here we've done the exact same that we've done before by compiling, also returning the model, and actually specifying that this is what we want to do here. And now we want to tune the batch size with the number of epochs that we have, or the number of iterations, and then select kind of the best set of parameters that we have that will help give us the highest accuracy. Because by the end of building any kind of deep learning or machine learning model, our goal is to have the best and the highest number of accuracy to make sure that our model is actually performing extremely well. So that is what we will actually do. So let's tune the batch size and the number of epochs by running these line of codes. So we'll specify the parameters here. For the batch size, it will be a 50 and 100. The epochs will be a 50 and 100 here. This is where we kind of select the best set of parameters that will help give us the highest accuracy. So by running this line of code and seeing a summary of what we have, this is basically what we will get. Let's look a bit into the last few examples here. This is what we get, and we will specify the best set of parameters that we have. Obviously, as I mentioned, we have the batch size of 50 and the epochs of 100. And this, after running this line of code, this actually shows us, obviously, that we have the highest accuracy, which gives us around a good 86 to maybe like 87%, which is actually showing, obviously, after doing all these steps, that this is the highest accuracy level that we can get. Now we want to fit our model on the selected hyperparameter, as we mentioned here, on the selected hyperparameter values, and retrain and reevaluate it for further analysis. So this is kind of the last thing that we have to do. So we will obviously, as I mentioned, this is where we fit our model and obviously train and test it with the number of epochs and the batch size here, that with the parameters that we have chosen. And we will go down and just check here what the accuracy has been. And here we can kind of confirm, obviously, as we go down a bit, that most of our kind of look at the accuracy. Let's go down a bit. So the kind of here you can see that the accuracy lies around like an 86 or 87% or 88 even percent almost. This is the kind of highest accuracy that we can see, and this actually confirms that we have a great result. So after kind of building the model, we can actually confirm that our model is performing very well. We have a good accuracy of 88.62% number, which means that if you give our model like a kind of if you want our model to predict if a patient has a stroke or not, it will be able to do that, giving us this number and this accuracy. So we are kind of done with these steps for the building the actual model. Let me just go look back here and see the different comments we have. Okay, now we are almost done for today. I hope you kind of obviously understood and learned how to build your first deep learning model or deep or machine learning model to predict that if someone has a stroke or not. So before we kind of give you some more learning resources and such, I'm going to kind of give you the final thing that we want to talk about today is some tips and tricks on how you can get started into the data science, machine learning, or AI field, because they're kind of all similar in some way. So as a regional cloud advocate and data science and data analyst expert myself, I have gathered for you the best tips and tricks for you to actually get started into this field. So the first thing you're going to do is you want to get yourself familiar with the core concepts that you have. So we have to be familiar with the core concepts, we have Microsoft Learn platform and the GitHub platform. So if you go to Microsoft Learn or the GitHub platform, we have some amazing learning modules on Microsoft Learn, free learning path, free learning modules, and basically different levels. So if you're a beginner, if you're in intermediate or advanced, you're looking for these kind of courses or these also certifications or some courses to kind of give you a boost on to learn like a new concept or something in the tech field. Like, let's say you're interested into learning more about Python, or maybe let's say you want to learn about deep learning models, you want to learn about machine learning, data science, you want to learn about Microsoft Azure, you want to learn about basically whatever topic you have. Your best bet and your best guide is the Microsoft Learn platform. So if you check our Microsoft Learn platform, free learning resources for you to actually continue with your learning journey, as well as building the core concepts or the foundational concepts that you need to know in order to help you get started. Also, we have a GitHub also obviously we are all familiar with GitHub. GitHub is another amazing resource and tool where you can have see hands-on projects, you can see different free curriculums done by our Microsoft team as well, which kind of serve as a guide for anything that you want to have in data science. So you've kind of got yourself familiar with the core concepts, you've understood the different definitions you have, all the kind of different examples and such, the algorithms and such. What's your next step? The next step is to learn a programming language that you would be comfortable with. If you're only getting started, your best bet is Python. Python is kind of very easy to use. It's beginner friendly. It's an open source. It has absolutely amazing libraries that help with doing kind of all data science work for you, such as data manipulation, visualization, and so much more. So definitely, also, if you are not familiar with Python, you can go on our Microsoft Learn platform and search for some Python courses. And even on GitHub, you would have some projects that actually use Python. So start by learning a programming language. I obviously recommend Python because it's the easiest to use and it's just amazing with all the different libraries it has. The third step is to actually learn data analysis, manipulation, and visualization. And this is where you actually start by looking more into the libraries. So this is where you use a pandas library. With pandas, it's used for data manipulation and statistical analysis. So it's very useful for you to actually start practicing and looking at all the different features of pandas, how pandas work, and all that stuff. Then you will move on to learning machine learning. Machine learning and deep learning, obviously, to use that, you can use scikit-learn and you can use TensorFlow libraries as well. So do some research on that, understand your machine learning basis, build a solid ground for that, and based on that, you are good to go. Then your next bet and the best bet that you really have to do is to actually start by actually working with your hands. So you've built all your foundation concepts, you've learned your programming language, you understood the different machine learning algorithms, what to apply on what, and all that stuff. You need to start actually practicing. So start doing some research, get some free, there's some open free data sets out there. We live in a world where the online community obviously We have amazing resources and links for free as well. So obviously start by looking at a project that you really like, something simple such as building a classification model. Look at how you can build a prediction model or regression model, clustering problems as well. So start by looking at the different ways of how each one is done and actually start practicing to actually start building the confidence that, okay, I got this, I can do it. And lastly, and most importantly, this is one of the most important kind of tips that I would give you if you're only getting started and if you want to get started into the data science field, is to connect yourself with a data science community. So look around you and try to find any kind of meetups or opportunities, or maybe, I don't know, like conferences as well. Try to look for like a meetup in your area that really could kind of inspire you to meet kind of other like-minded people, where you can kind of share and exchange ideas, also to know about any other different ideas about the field, what's new in the industry, and so much more. um, this is actually the best thing that you can do. Or obviously attend such sessions like these are very helpful for you, where because you can ask questions, you can also network with other people as well, and basically it just kind of helps you basically kind of feel like you have this community that is built around you. So these are my tips on how you can actually get started in the data science field. Now, I am going to actually share the learning resources that you can use for your learning journey. So obviously we are at the end of our data science three-part series. If you want to actually continue learning at your own pace, you've missed maybe the first two sessions and you don't know what we have covered, your best bet is these two further learning resources that I have here. So I'm going to give you a minute to actually scan them really quickly, and to do and before you scan that, I'm actually going to post them in the chat box that we have here, so you can actually use them. So I'm just going to copy them really quickly. And the next one is a learning module. And the last one is a machine learning cheat sheet as well, which is the one that we have shared previously. So definitely check those out, those free learning resources, free learning links. Absolutely amazing, very helpful. They really do help with kind of getting started into your data science journey. So the first one is a GitHub curriculum, which is built by our Microsoft team. Amazing. This is an amazing beginner-friendly curriculum, which has absolutely amazing resources and a guide on how you can actually get started into data science. It's the curriculum is built in for beginners, for even if you're intermediate and you don't know where to get started. This is your best guide. So check it out, scan the QR code, or check out the link that I've posted in the chat box. The next link that you have is actually a learning module on our Microsoft Learn platform. And this is absolutely amazing for you to get started and learn Python and data science concepts as well. So highly check these two out. These are ones that I always use in my sessions. Very helpful. You can always go back to them. Obviously, if you're getting lost, if you're getting stuck, if you want to learn about a specific concept and you don't know where to start. And they also have some examples and projects as well, which are built in, which give you kind of, you won't really learn until you actually see use cases and examples. So highly check these out. The next link is the machine learning algorithm cheat sheet that we have as well. You can scan the QR code here or check the link that I've posted in the chat. It's basically aka.ms/ml cheat sheet. So have these as a guide with you. I would highly recommend for you to check them out, and obviously complete the learning modules and the GitHub curriculum, and have this machine learning algorithm cheat sheet for you. And then I would believe that you would be ready to take on and have the confidence to build your first data science model. That being said, we are done for today. So thank you all so much for joining us. If you would like to stay tuned and know what I'm up to next, so next time, if you are a fellow Arabic speaker, if you're a fellow woman in tech, we are launching this Microsoft Reactor. We are launching this new D&I initiative, or a new program and cohort, which is specifically targeting Arabic speaking women in tech. So this is basically, I'm going to be having obviously Arabic as experts, cloud advocates, and speakers who are absolutely inspiring, and they will kind of share their success journeys into tech, how they got into the field of women in tech, as well as there are going to be some skilling sessions. So some will be covering some kind of Microsoft Azure concepts, how to build Azure apps, how to kind of look at Microsoft Graph and M365. We're going to be looking at artificial intelligence and data science, and so much more. So if you are a fellow as Arabic speaker, if you're a woman in tech, if you know someone, let them stay tuned. The first episode will launch on 7th of March at 5 p.m. GST. The next episode as well, after that, we have the Microsoft Azure series. So I'm starting in March a three-part Microsoft Azure series where we actually go through Microsoft Azure fundamentals, concepts, explore machine learning in Microsoft Azure, explore compute concepts and such. Microsoft Azure is absolutely an amazing platform which has huge, amazing kind of technologies and built-in cloud solutions for any problem that you have. So we're going to kind of explore the Microsoft Azure platform, and we will start the first session will begin on the 9th of March at 4 p.m. GST. It will be a live stream event as well, so stay tuned for that one as well. That being said, we are done for today. Thank you all so much for being here today. I had a pleasure, and that being said, I look forward to seeing you next time. Thank you all so much. I will stop sharing my screen now, and please let me know if you do have any questions, or any kind of comments as well. I am going to share here as well these different, obviously, links that we have on screen before we end. And that being said, thank you all so much for joining us. Take care, and I'll see you next time. Goodbye.